and Dalton's atomic theory. The law talks about two types of changes, physical and chemical. Let's look at an experiment.
So physical change are those changes we can reoccur, means initial state and final state can be reproduced, but the chemical changes are those substances which cannot be recurrence, means the initial state cannot be further founded.
To verify the part about the physical changes, let's place some ice cubes in a dish and weigh it. Let's say that the weight is X. If we heat the ice, it will melt and form water. If we weigh water, we notice that the weight is the same as the weight of ice. This proves when matter undergoes a physical change. Like in this case, the total mass of the reactants is equal to the total mass of the products. Now, let's verify the part about chemical changes. Take some sodium chloride and silver nitride in a tube. Now, let's seal both the tubes with a rubber cork. Let's weigh the tube and note the weight. This is the weight of reactants before taking chemical reaction. Now, tilt the tube to mix the solutions thoroughly. Reaction takes place, and we notice that a white precipitate of silver chloride is found in the tube along with sodium nitrate solution. Let's weigh the tube after the reaction. We observe that the weight remains the same. Thus we can conclude that when matter undergoes a chemical reaction, the total mass of the reactants is equal to the total mass of the products. That is, during any chemical reaction, matter is neither gained nor lost. Hence, this law is also called the law of indestructibility of matter. Now, let's look at the next law. Law of definite proportions.
So these are our very simple definitions and laws. Already you have studied in class 9th. That's why whenever you will come out to school, I will explain thoroughly, but there is nothing to explain more peculiarly. You can see that.
As the name suggests, this law deals with the composition of various elements present in a compound. In 1799, Joseph Proust proposed the law of definite proportions. This law states that a pure chemical compound always contains the same elements combined together in the same fixed ratio by mass. For example, the water we get from any source such as river, well, lake, sea, or from any other place always contains.
So it's a very common example. If you are taking a water from the sea, if you are taking pure water from the RO, if you are taking the pure water from well, if you are taking the pure water from drain, everywhere you find that the hydrogen and oxygen ratio will be 2:1. So it is called law of definite proportion.
Hydrogen and oxygen elements in the ratio of 1:8 by mass. Thus, we can say that a given compound always contains exactly the same elements in the same fixed proportion by mass. However, this law does not apply if an element exists in different isotopes, which may form a compound.
So this is a drawback of law of definite proportion, that if elements are present in the isotopic form, then the law will not be obeyed. For example, carbon exists in two isotopic form, carbon 12 and carbon 14. Hydrogen also exists in three isotopic form, protium, deuterium and tritium. That's all.
For example, if a carbon 12 isotope combines with oxygen to form carbon dioxide, the ratio of carbon to oxygen is 3:8. But if a carbon 14 isotope combines with oxygen, then the ratio of carbon to oxygen is 7:16. Another limitation of the law is that elements may combine in the same ratio, but the compounds formed may be different. For example, the compounds ethanol and dimethyl ether have the same number of carbon, hydrogen and oxygen patterns, but their arrangement is different. That is, the compounds are different. In 1804, Dalton proposed the law of multiple proportions. This law states that when two elements combine to form more than one chemical compound, then the masses of one of the elements that combine with the fixed mass of other element bears a simple ratio. For example, when the elements
again, it's a very simplest form.
Two compounds, namely carbon dioxide and carbon monoxide, can be formed. As seen in the equation for carbon dioxide, 24 parts by mass of carbon combines with 32 parts by mass of oxygen. Whereas, when carbon monoxide is formed, 12 parts of mass by carbon combine with 16 parts by mass of oxygen. These masses of oxygen bear a simple ratio of 32:16 or 2:1.
Got these points? Very simple.
A fixed amount of carbon is combining with multiple proportions of oxygen to form carbon dioxide and carbon monoxide. Similarly, when sulfur dioxide and sulfur trioxide are formed, the masses of oxygen bear a simple ratio of 32:48 or 2:3. In these reactions, a fixed amount of sulfur is combining with multiple proportions of oxygen to form sulfur dioxide and sulfur trioxide. In 1808, Gay-Lussac put forward a generalization which defines the relationship between volumes of gas.
So students, Gay-Lussac law is important. I will explain it on my next video. Thank you and have a nice day.